fine. So if you recall, the way to solve these complex pulley diagrams is to start with T, label everything in reference to T, find a spot wherein you set up an equilibrium equation, ups equals downs, and then solve for T. Okay? There is one spot wherein you should solve this particular pulley problem. Where is that? Where should you set up the final equation? Say it again, Gina. At the 11 Newton weight. Why? Yep, because there's 1, 2, 3 strings attached to it. Thank you. And so this is where the final equation is going to be set. Because if I were, let's say, started here at T and went around and labeled everything and then tried to jump up here and, you know, label the amount of tension supporting the 11 Newton weight, it's not symmetrical, it's a little crazy. Do I split it half and half? Well, maybe it wasn't 50-50, maybe it was 60-40, maybe 2/3 of the weight was held on one string, 1/3 on the other. So instead of trying to determine that, make this your final resting place, sort of, okay?
And that's just where we come to the top and bottom.
Yes.
Can we talk about real quick how you know when to subtract the weight? That's
Sure.
the part I can never understand.
Sure. So let's just solve this. So we're going to start at T. So if this is T, what must this string tension be? T. It's the same string. This, T, and this, correct. How about this string?
T. Oh, yeah, T. I'm so sorry.
2T, right. Ups equals downs. And remember that if you chunk this and you do like step by step, now I haven't dealt with the 2 Newton weight yet. So I just look at that. I just look at this single pulley and ups equals downs. Now I deal with the 2 Newton weight. So yeah, hold on. This string has to hold up 2T and it has to hold up 2.
Oh, right.
Yep, 2T plus 2. Okay? Another way to, like a mnemonic device to remember this is when you go up, you add. If you go down, you subtract. So let's say that this was T, this string tension right here. This tension would be T minus 2. So when you go down, you subtract. When you go up, you add. And it just makes it work so that ups equals downs. Okay?
Is that just a rule of thumb or is that like absolute?
Well, it always works. So, okay. All right, but once you've committed to a string, as in all good relationships, you must stay committed. Stick with it. Don't cheat on your string. Stay with that string tension. 2T plus 2 is all of this, correct? Audrey? I might have like a little packet of tissues in my purse. You want me to check? Okay. And we're recording. Okay.
Sorry.
Wait, isn't that...
So go ahead and fill in the rest of these. Go ahead and fill in the rest of these and see. Oh, you are a good person. Hey, he's a Renaissance man. Always be prepared.
I got batteries, water, food. In case if something like this happens, I am prepared.
And in case he needs to block his nose while he's tearing someone's head off.
Yes.
Or what if he gets a little, like, emotional, something poignant happens, he can dab, right?
Yeah, like his cell phone instead of batteries starts crying.
Exactly.
Will you cry? Get your bike?
All right. Fill these in. Let's go.
First pulley,
This one right here?
No, where is it?
This?
Yeah, that one.
Yeah, that is. It doesn't matter because but yes, that's correct. I mean, it doesn't really impact the final equation, but it's no problem to label it.
So, second down, would that be 4T plus 4? That one?
This one? Yeah.
And then, are you going to go over how to do
All right, everybody good? These, by the way, these 2 top strings are also 4T plus 4. It doesn't really have an impact because we're really wanting to know what affects this. So we've labeled everything now. So this whole string is 2t plus 2. Yep. And then this is double that, so 4t plus 4. Now, the final equation is going to be everything that holds up the 11 Newton weight and everything is equal to everything that pulls down on the 11 Newton weight, including the 11 Newtons itself. Okay, so that's easy to miss. So the final equation is ups equals downs. So 2t plus 2, how about we move that up a little bit, plus 4t plus 4 equals 11 plus t. Yeah. That's because we're not really transferring the tension. We're just stopping at that point. And 11 acts down. You would be correct if we were like trying to take these string tensions and transfer them and then keep on going. Okay? So once you find that final stopping point, equilibrium point, that's when you just set ups equals to downs. And then solve.
I'm a little bit confused over why you're adding less and not subtracting. Because we're going down the string.
That's what Michaela just asked.
Yeah, I know,
You didn't get the,
No, I
okay.
didn't.
All right. You get that we've labeled all the string tensions, right?
Yes, ma'am.
And wherever the final equilibrium equation is, you do ups equals downs. You only do that add when you go up, subtract when you go down if you're continuing labeling the string tensions.
Okay.
Once you get to the final equilibrium spot, just ups equals downs.
I mean, you could add it to the negative 11, it would be on the other side.
You could do it that way, absolutely. Yeah, I thought that would be confusing, though. Maybe not. Does anybody here, Jesus? Okay, you could do, listen, you could do minus 11, because you go down, subtract 11, but that negative 11 needs to be on this side of the equation. Yeah, if that's confusing, then ignore what I just said. If you're like, oh, that makes sense, then do that. Okay? You probably can do the algebra that's going to give you the same answer. What's the answer to this?
Is it like 1 year?
Yes.
Okay.
Okay.
Remember on the second test, you put out like